Hello students, today we'll discuss about forming processes. The topic covers in manufacturing process for semester. First of all, we'll discuss about forming process. Practically all metals which are not used in cast form are reduced to some standard shapes for subsequent processing. That called the forming. The manufacturing companies producing metal supplies metals in form of ingots which are obtained by casting liquid metal in a square cross sections. These square cross sections have a different names according the size. Slab. Slab have a 500 to 1800 mm wide and 50 to 300 mm thick, that is known as slab. The billets. Billets have a 40 to 150 square mm that called billets, and the blooms that called and the 150 to 400 square meter of the cross section area that are called blooms. Sometimes continuous casting methods are also used to cast the liquid metal into slabs, billets, and blooms. These slabs are further processed through hot rolling, forging or extrusion to produce materials in a standard form such as plates, sheets, rods, tubes, and structural sections. The basic sequence of operations for obtaining different shapes here. The first ingot, which is you are getting by the hot rolling process, and slab in form of slab, and then again hot rolling and getting plates and sheets, and again cold rolling, and then produces thin plates or sheets. And the second process ingot produced from the hot rolling, and then billets find, and the next step again hot rolling and in convert bars and rods, and again drawing, then finally produces bars and wires of this process. And bloom produces from the ingot hot rolling, and the bloom go for next operation hot rolling, and produces structural sections, rails, like this figure. We can see in this slide the various figures of and sequence of operations. Bloom, the structural shapes which is used or application of the rail tracks, and the slabs produces the plates and sheets, and finally coils, and blade produces bars, rods, etc. as shown in the slide. Primary metal forming processes are the rolling process, forging process, extrusion process, tube and wire drawing process, and deep drawing process. Although punching and blanking operations are not metal forming processes, however, these will be covered due to similarity with deep drawing process. Rolling. We can see in the rolling the two rollers here, and both rollers move in opposite directions, and the work in between two rollers and the direction of the workflow and thickness reduces of the billet and sheets by the pressure on the rollers, and squeeze the metal which passes in between two rollers. We can see in this slide, and the Second figure here is, we can see here, unworked crystals like this shapes, and after squeezing or rolling of this billet here, and elongated crystals shape this like this, and that direction of the travel, and the friction force work on in between roller or a billet or a workpiece like this. Change in grains structure and rolling like this in figure A, the ingot with non-uniform grains here, and the in figure B, hot rolling process here under rod produced with large grains, and after rolling deformed elongated grains, and new grains forming here, and new grains growing, and recrystallization is complete here, and the reduce the cross section area after this rolling process. Silent points about rolling. Rolling is the most extensively used metal forming process, and its share is roughly 90%. The material to be rolled is drawn by means of friction into the two revolving roll gaps. The compressive forces applied by the roll reduce the thickness of the material or change its cross-section area. The geometry of the product depends on the contour of the roll gap. Raw materials are cast iron, cast steel, and forged steel because of high strength and wear resistance requirements. Hot rolls are generally rough so that they can bite the work, and cold rolls are ground and polished for good finish. In rolling, the crystals get elongated in the rolling direction. In rolling direction, in cold rolling, crystals more or less retain the elongated shape, but in hot rolling, they start reforming after coming out from the deformation zone. The peripheral velocity of rolls at entry exceeds that of strip, which is dragged in if interface friction is high enough. In the deformation zone, the thickness of the strip gets reduced and it elongates. This increases the linear speed of at the exit. Thus, there exists a neutral point where roll speed and strip speed are equal. At this point, the direction of the friction reverses. When the angle of contact alpha exceeds the friction angle lambda, the rolls cannot draw fresh strip. Roll torque, power, etc. increases with increase in roll work, contact length, or a roll radius. Students, these are the basic main points about the rolling operation. The keep in your mind or the questions raised in competition purpose or in your end term examination purpose. Thank you.